Okay, so let's say we're thinking about the distance issue here, okay, or the distance problem. So let's say we have something that's moving around and we take some snapshots of its velocity as it's moving. That's what this little table is. So I have that as time. I labeled these things wrong. The time is given in the top and the velocity is the bottom row. So let's say we want to know what the total distance is traveled. Let's total distance traveled from t equals 0 to t equals 4. Now, we could estimate that and say, okay, well, if we just look at our little table and say, well, it starts off at 5 feet per second, okay? So this is in feet per second. Say it starts off at 5 feet per second at time equals 0. And we let that, the velocity is not changing a whole lot, so we could kind of estimate that and say, well, distance equals rate times time, right? So for that first interval, at d equals 0, it's traveling at 5 feet per second. We can say, well, it's going to travel that for 1 second. That's our estimate. So that's a total of 5. Now over that next little time interval, its distance has increased to 8, right? So, its velocity has increased to 8. So it'll travel 8 feet per second for that next second. That'll give us a total of 8 feet. Okay. In the next little time interval, it's moved up to 11. And then the next time interval from 3 to 4, it's approximately moving at 14 feet per second. So in that 1 second, it moved approximately 14 feet. So I could approximate the distance to say, well, that's 5 plus 8 plus 11 plus 14, which is 38 feet. Okay? Now, if you'll notice, really what we've done is exactly the same thing with the area problem. 3t plus 5. So we have, if we think about our velocity graph, it looks like this. Okay? And if we split that up into those 1 second intervals, all we did was look at, okay, well, at time t equals 0, how fast was this sucker going? We evaluate the function, that's our y-coordinate, right? And we multiplied it by that 1 second interval that it was traveling that speed. And then at 1, we multiplied that. And so look, we're just finding the area under this curve. Okay. So our velocity question, or our distance question, boils down to exactly the same thing we did in the last video with the area problem. We're just finding the area under the curve. Just our curve needs to be a velocity to get this distance for the total distance traveled. So we could, of course, get more accurate if we had smaller intervals or stuff like that. This one is the left endpoints, because that's what I chose to use on this one for just because. We could use right endpoints and all of that stuff. So when you see the distance questions, just keep in mind it's the same as the area. We're just doing Riemann sum type things. And good luck with it.